Think through this line of reasoning with me. It's very common thinking as we consider what's happening in organic reactions. Organic reactions are making and breaking of covalent bonds. Covalent bonds are shared pairs of electrons. Two atoms between them share a pair of electrons. That shared pair of electrons often comes from one atom donating the electrons in a bond-making process. The driving force for a molecule or an ion to donate a pair of electrons is attraction to positive charge. Electrons, remember, are negatively charged, and negative charge is attracted to positive charge. So the driving force for formation of bonds, which results from a donation of a pair of electrons, is attraction to positive charge. And we call those ions or molecules that donate a pair of electrons a nucleophile. Here are some examples. When an organic ion, a carbon atom that has a positive charge, is together with a bromide ion, a bond is formed, as shown by this equation. We can account for that by recognizing that bromide has a pair of electrons to share. It acts as a nucleophile. And using our arrow pushing to track what's happening here, we see that that donated pair of electrons from bromide to carbon makes a new bond. Here's a second example. When a molecule that has a carbonyl group in it, carbon double bond oxygen, is together with methoxide, an anion with a negative charge on oxygen, that methoxide adds to the carbonyl, as I've shown in this product here. We can account for that by noticing that this oxygen has a pair of electrons to donate. That pair of electrons can form a bond with that carbon. Two things. One is, why would it do that? Well, because the oxygen and carbon have different electronegativities. Oxygen pulls the electrons more than carbon does, and therefore there's a polarized double bond here with a partial negative charge on oxygen, and importantly for us, a partial positive charge on the carbon. So this negative electron density associated with the electrons is attracted to that positive charge. But how can this bond form when the carbon already has 8 electrons around it? That pi bond must break and that pair of electrons go up on oxygen, which we can write here just to help us remember they came from the pi bond. And here's the new bond we made by the sharing of a pair of electrons from methoxide, oxygen, to carbon, as shown by our arrow pushing. In both of these cases, the ion that donates a pair of electrons is a nucleophile. They're nucleophiles because they fit our definition of sharing a pair of electrons with carbon to form a new bond. Now take a look at this. Something else happens when we put this same carbonyl compound together with this same nucleophile, methoxide. A second type of reaction can happen that involves oxygen again sharing a pair of electrons, but this time with a proton. And as that happens, this bond needs to break, and so that pair of electrons goes to carbon. And here they are, which results in a negative charge on that carbon atom and the formation of a new bond. Now conceptually, this is exactly the same thing that we wrote up here, where we called methoxide a nucleophile, as it formed a bond with carbon by sharing a pair of electrons. When this same methoxide shares a pair of electrons to form a bond with hydrogen rather than carbon, we call this a base. It's the same ion doing the same kind of thing. The only distinction, and this is an important one, the only distinction is that the sharing of electrons is with carbon to form a bond between carbon and oxygen. We call it a nucleophile. Or the sharing of the pair of electrons is with hydrogen, a proton, which is abstracted from the organic molecule. We have a new bond between oxygen and hydrogen. And when we form the bond between oxygen and hydrogen, we call that a base, not a nucleophile. So, in terminology in organic chemistry, we talk about nucleophile, having a pair of electrons to donate for bond making with carbon. And when that pair of electrons is donated to make a bond with a proton, a hydrogen, we'll call it a base.